All right, let's take a look at the protocols, the most used protocols, and the details on them, the points that they want you to remember. OSPF, open shortest path first. IGP. So what's IGP refer to? Internal Gateway Protocol. It's a link state protocol. So what is the state of the link, up, down, and so on? Used on interior or border routers. So used in border routers and those that are just interior routers. What are the characteristics that they want us to remember from this? Supports large networks, imposes no hop limits like RIP does. RIP is the oldest routing protocol. Interesting story behind all that. The mother of the network, we'd have to look her up because I can't remember her name. Perlman? No, it wasn't Rita. Anyway, she worked at SoCal or Berkeley. Anyway, their network, their LAN back in the day was getting pretty big. And so her and her husband actually designed the first router, and that became Cisco. So they were eventually pushed out of Cisco, as usually happens in a business. But they had this RIP protocol, and we use RIP version 2, but it has a hop limit. So the network cannot be super huge. And you may say, well, why would you do that? Well, a lot of it just has to do with processing. The router has to process that information, and it's recording how many hops there are. And that means the database table is larger and more information to process. So open shortest path first does not impose a hop limit. And again, a hop is I need to get to X network and I go through 7 different routers to get there. So each one of those is a hop. There's 7 hops to that different network. Again, if you do a trace route, then you can see that. Has a complex algorithm or a complex way to calculate the most efficient best path. So it doesn't just say how many hops, which is what RIP does. RIP is the easiest to understand and know, but it just basically looks and says, how many hops to that? 7. Oh, well, that's longer than 4. So we'll use 4 hops. So it's using a more complex algorithm to figure that out. Shared data maintains a database of other router links. Low overhead, meaning that it's still pretty slim. You're not saving a lot of data in that. So one of the results of that is a faster convergence. Again, meaning that all the routers now understand where the routes are. That's what convergence refers to. The ability of all the routers that are talking with one another to have the same story, the same table, the same routes. And then stability uses algorithms that prevent routing loops. Obviously, that would be a problem. You got an internetwork of devices. There's many different ways to get there. So the information might be routed back to you. We don't want that to happen. Didn't I see this data? So the ability to say, okay, we're going to track and map out this network far enough and well enough that we're not getting data back. And then, of course, it's supported by all modern routers, meaning that I don't have to go out and buy 10 Cisco routers. I can buy all sorts of different routers, and they'll understand OSPF. It's set. Oh, let's need to open the cart over here. Didn't have to do that. So, yeah, if you want to. No, not surprising. This is the one we're talking about first. Let me pull up this other screen. Okay, there we go. Next one is intermediate system to intermediate system. It is also an IGP and link state protocol. Uses best path algorithm, similar, and it is designed for use on core routers only. So in other words, if you got a large network and you got 7 core routers that you're dealing with, this is the protocol that you'll use for those routers talking with one another. And then, of course, enhanced interior gateway routing protocol. Advanced distant vector protocol combines some of the features of a link state, often referred to as hybrid, because it's using both link state and vector. Offers fast convergence times, easier to configure, less CPU intensive, supports multiple protocols, and limits unnecessary network traffic between routers. What that's referring to is, okay, let's just be honest, IP version 6 and 4 is pretty much what we all use, but you can use multiple protocols with this particular one. Originally was only proprietary to Cisco. So the routing protocols were not good enough. Cisco made their own, but why would you share that with the world? That's one of the things that makes you different. So originally it was only for Cisco. And BGP, Border Gateway Protocol, the only current EGP, Exterior Gateway Protocol, known as the routing protocol of the internet. Spans multiple autonomous systems. Special characteristics include path vector routing, efficient, customizable. So why not just use this for everything? Why do we have different protocols? Maybe someday we'll get to the point where all routers will just be so fast at computing everything that they'll just all use the same protocol. Won't matter. We like doing that as humans. So there is a chance for this to happen, because then you don't have to be the router specialist that knows how to use OSPF and is and BGP and their differences. Instead, you just use one to do it all. However, this is the most complex. So the routers that are running this are going to have to be faster. Processing is going to have to be faster. This is going to be more costly. So your border router is not going to be the same as your core router. Large networks should have multiple ISP connections. So talking about WAN technologies. Large networks will have multiple ISP connections, but smaller networks won't. I don't know how they have it set up here at EA. I know they have multiple connections, but I don't know if they're load balancing and sending some out this and some out that, or if they're just got that backup channel, right? That it's ready for, oh crap, that one's going bad, and then they just plug it in. I don't know. So, type of routing redundancy, active redundancy, all redundant resources are active at all times. And that's what I mentioned first. All that traffic is distributed among them. We have different ways to get there. If one becomes too overloaded, then the other is going to be kicked over. And then there's different ways to get that done, round robin and all sorts of things. Or active passive, only one or a few redundant resources are active at any time, with the backup devices on standby. And that might be more automated. So it might be, oh, I'm checking all the time to make sure that that internet gateway is open and working. And when it goes down, I come online. Or it's, I just got a message that the internet's down and somebody goes over and plugs it in, because that's passive as well. So what do we do in routing redundancy to have different connections to the internet? Well, you've got the first hop redundancy protocol. provides a virtual IP address as the default gateway. And then you also have host standby routing protocol and gateway load balancing protocol. Now, I know that's a lot of information, but again, what they're trying to give you enough to understand how this is working. That's why I spent time talking about, hey, you can have these different connections to the internet, but they don't all have to be on. Why? Because that's expensive. You can pay for a backup channel that's just there when you need it, and that's cheaper. So there's a lot of options in networking and in WAN technologies to put in place what you need. So it's really important to understand, hey, that's the concept. The concept is I've got a facility where I have 1,000 employees. And these days, if I lose the internet connection, we might as well all go home. 25 years ago, that was not the case. The internet was just something fun to have. It helped you out. Now you need it. You have to have it. And in most of those businesses, most of their stuff's going to be on the cloud. So if you lose your internet, they can't even get to their mail internally. So how do we provide this? Well, there's lots of ways to do it. How much money you got? You got a lot of money. We can have 3 other connections. They're all going. We've got active redundancy running across all of them. Oh, you don't have that much money? Okay, let's go active passive then. And then how do we check to make sure, is this up and running? How automatic does it need to be? As I'm sitting there as the head network tech, and all of a sudden I get 100 calls saying the internet's down. I don't want that. I want it to just kick over. And I want to get a little text from my equipment that says such and such just kicked over, problem with. I go, oh, okay. Nobody else noticed. I can go work on it. Boy, that gets into a whole political thing. If you are using, if you're the guy that's setting up internet these days, all these technologies, you really want it to just run flawlessly. But there is a problem behind that. And I'm serious. This happens to so many network people. It runs flawlessly. And so then they go, well, I don't know why we're paying you. They really have that attitude. It's sort of like saying that you have a vehicle and unbeknownst to that person, every single night you take their vehicle and make sure it's working correctly and then take it back. So the vehicle's always working and they fire you because they're like, why do I need you? And you're like, yeah, but I was coming over every night and taking your vehicle and make sure it was working right. So you say. And then, of course, a few weeks later, the car breaks down. And that happens the same in networking. You set up all this fancy technology. As a network person, like a lot of IT people don't talk about themselves and they don't talk about what they're doing. You have to. You have to tell them, we have these things in place. It costs us this much money. We bought that router for these reasons. What does that do? This is what it does. Then they understand better. Oh, okay, you're doing all this stuff. There's a lot that's going on that I'm not aware of. I thought maybe you just plugged in these boxes, just like you plug in an Apple TV, and there it goes. It just starts working. No, it's not. It's not how that works. It does. It becomes a problem. Oh man, do we really need a network tech? I know a guy that happened to. He's like, do we really need a network tech? He's like, you realize why everything's working. Should I report every problem to you that I fix? Well, actually, in that situation, it probably would have been good. At least log it. Maybe we had this problem and fixed it today so that they know. Any case, that's not textbook stuff. All right, so WAN connectivity options. How do we then make these connections? Those connections that we're going to make redundant or whatever we're going to do with them, how do we do it? Well, we've got broadband. Broadband means this. So you have a channel that you're going through. If we could like look inside that cable. We have a channel, and broadband is just basically like an analog signal. It's just going to fill up this channel. Baseband, if we have baseband, is binary. So you have a 1 and you have a 0. That's baseband. So these days, when you say broadband, people are, well, that's fast. Yeah, that's what marketing does to technology. They always screw up whatever it is by trying to simplify it for folks and trying to sell it. So broadband. Bandwidth is shared between multiple customers. The ISP makes a best effort attempt to provide up to the advertised bandwidth. That's all the internet you use. That's what you get. So if you're using around here, you got fiber optic through Valley Telecom, or you've got DSL through the telco, whatever their name is now. And honestly, whatever the name of the cable company is now, because that's changed 3 times as well. Broadband. That's what you're using. So you get dumped into a big pool and they say, hey, from your house, you're paying for 100 megabit because you want to just have everything in the world. Well, everybody, and this is the truth. It's NFL. We're going to have the Super Bowl. Yeah, you're not getting 100. Everybody's going to be online streaming that, looking at it, getting report, whatever. They're going to just pound the crap out of that. And so what they're doing is basically saying, well, how much bandwidth do we have total from us? How much bandwidth? What is our connection? So let's say that they have 1 gigabit. That's what they have. And then they go out and sell. So how many of these 100s can we sell before we run out of that? Mega to giga. Times 10? Times 10. So we go out and give 10 people 100 megabit. And we used up our gigabit. Now, here's the thing. That's not really the way we use this technology. It's very much like a CPU. I got a really fast computer here. We look up our task manager. Just going to pop up. Oh, good. It popped up over here. Usually doesn't do that. So we've got these fast CPUs looking at the GPU there. Let's go to the CPU. And it's not fully used. It's not going to be fully used. That's why when you see a computer that's designed for somebody in movie making, right, they're really gonna they're gonna get as much as possible because what they're gonna use that. They're gonna use it all the time. It's just gonna be pegged all the time at 100%. So we're not using it. Same thing with the internet. I am not using the internet right now. I am not clicking on pages. I'm not watching video. Not really using it. So we can go out and sell this times 100. We're going to be okay. Because we're not every single minute, every single second, everybody's using it. That's not the case. Just clicking on these things. This one's really got a heavy stream going. That one's really got a heavy stream going. You ever notice that really in night when everybody starts streaming movies, playing games, your connection slows? Yeah, so most people never think about this. They don't think about, well, what does my service provider have? Well, they have only got a gigabit link. They're selling it out to thousands of people. And yeah, it's probably not all 100 megabits. And that gives them the ability for your device to their device to throttle that. Say you get 20 megabits, 40 megabits, whatever they want to do. And yeah, they'll sell a gigabit to somebody. But basically, they're going to oversell this. If everybody starts really streaming a bunch of videos, it's jam-packed. This is going to be jam-packed full, 1 gigabit constantly. So the ISP says, yeah, we promise you 100 unless, and that's in their big statement. We will do our best to give you your 100 megabits, but we are not promising you 100 megabits all the time. Nope. You want that? You're going to pay some more. Bandwidth is asymmetrical, asynchronous, which means download speeds are faster than upload speeds. Asymmetrical, asynchronous means they are not the same. Synchronous means that they are the same. Or symmetrical means they are the same. So they know you're going to download all the time. So we're giving you 100 megabit. What's your upload speed? 10 megabit. Upload speed means I need to upload my files to the cloud. Upload speeds are heavily used if you have your own website. If you're hosting out your own game. Well, if you're going to host out your own game at your house to thousands of people around the world, then you're going to pay more money for that. And they do. That's why a lot of these will have a business plan. The business plan gives you more uploads, quicker uploads. And honestly, for me at home, I will pay more for a higher download because the upload will go up with that. And I am going to upload a crap ton of stuff onto the internet. Dedicated internet access. Oh yeah, that's what you want. You just can't afford it. Bandwidth is dedicated to a single customer. Bandwidth is symmetrical, which means download and upload speeds are pretty much the same. They'll do their best effort to give you that. This is important for business that back up large amounts of data online. So here at EAC, where, we have gone a lot to the cloud. So you log into Office 365 and you can store all your files there. I do. I can get it from my home. I can synchronize it with 10 different computers. I want that upload speed. Dedicated internet access. That costs you a lot more money. So realize that. That's one of the reasons why you would do a bandwidth speed test to see how things are going. All right, we're going to quickly move through this because really the thing that you need to understand is DSL is telco. And I already explained this on Monday, but you're using those little tiny phone lines that they put in there. Around here, I think they were upgraded sometime in the 70s. But it's still just these little tiny copper cables. Trying to get some distance out of that. It's not happening. Voice, no problem. Voice data is like, here's a draw our data channel again for different purposes. Here's your voice. It's filling up that. That's nothing. Video, yeah, that's filling up the rest. But voice, that's no big deal. So DSL, anytime you hear DSL, you think telco. They still use this PSTN, not joking. It'll be on the test. PSTN, public switched telephone network. When you dial a phone number, it would, in the day, mechanically switch the circuits. And then you would talk on that circuit to grandma in Wisconsin. You guys never had to experience this, but sometimes around the holidays, those circuits would get loaded. Because how many circuits can you take out of this valley? How many circuits can be taken out of Phoenix? In other words, how many direct calls can be made? And they're dynamically thrown together. And so you'd call and you get a really bad connection, so you'd hang up and do it again. Because when you called, it set up that physical circuit. And then when you hung up, it tore it down. When you call again, it sets up a different circuit. And just like the internet, they could route it all over the place. So you could go to Wisconsin by talking via Florida. However they can make that connection happen. Well, when the volume's not high, you got enough circuits so you can do what you want to with them. But when the volume got high during the holidays, then we got to get fancy with how we're getting there. So you need to know that, it requires a lot of repeaters. You got to take that digital signal in and push it out because you're using, this is the important thing, little tiny copper wires. You're using those little tiny copper wires. You're not going more than about 7 miles, and then you're going to have a repeater. That's a lot of repeaters to use that cabling system. The distance between the customer and the CO affect actual throughput. So you can get DSL around here, but it's more my speed is going to depend on how far I am from the office that I'm connecting to. And as I said, there's a switching station in Pima and there's one in Safford that's right over there across from the, you guys ever seen that place there? Probably not. It's right next to the city hall office. It's right across from that new pizza place. It's a little, that's where the switching station is. So and I can get DSL because I live pretty close to there, but it's crap. It's terrible. That's the main thing. And then here are our variations of what they have tried to do to make it better. And then, of course, cable broadband. Again, going back to that fact that the cable's better. It can go further. It's got a thicker core inside. That's why cable, right? That's cable television. That's what they started with. And then cable internet. And then, oh, you can get your phone through it now. Cable telephone. You can get all your services that all go out this protocol suite that your cable modem's using called DOCSIS, Data over Cable Service Interface Specifications. And you thankfully don't have to get too much into that other than to notice that the standard is 4.0. But if they move up to a different standard, that means you usually have to get another cable modem because that stuff's in the firmware. And then you can go really fast. Up past that, such as 70 megabits download, 7 upload, yeah, such as they can give you a gigabit over that. That's not a problem. And then you deal with this HFC because in a lot of cable systems, not around here, but in Phoenix, they actually would just, from the cabling office, would just run fiber to that neighborhood. So they'd run fiber to this 6-mile neighborhood, and then from there run coaxial. So the coaxial only has to hit the fiber, and then now you got this really fast fiber channel that goes back to the cable company. Any of you lived in Mesa or Phoenix or been over there and seen their ads? They have these ads that'll be like super fast internet. It's true. It is true. And this is often what they try to set up. So they've got these fiber rings. They've got 2 of them because these are geographically going to be dispersed. So they're trying to fit it in this picture, but there may be hundreds of miles between these. So they'll have one fiber ring and then a backup fiber ring. And then the nodes that they hit through fiber, and then finally coaxial to your house. Fiber to your house. Oh, look at that. We got fiber to your house. It's really no big deal. This works just as well. Because it is about how much can I shove down this coaxial cable in that short distance. We have not hit the top of that yet. So that requires a cable modem. So on DSL, you get a DSL modem. On a cable modem, you get a cable modem. And sometimes everything's built in. This is what I have, fiber to the node. And that's basically because I was on the cable modem system. I was on, what are they now? Sparklight, yeah. I know some people that work for them. Anyway, they just started upping you automatically if you use too much bandwidth. So they started running it like a telephone. Of course, now on your telephones, you just get unlimited data, right? But back then when they started doing this, if you downloaded too much on your telephone, then they would up you. So they decided to do the same thing. So after they upped me, I'm like, see ya. Because I knew that there was fiber. And with fiber, they ran it all. So the fiber was already outside my house, just sitting there. All I did was call them and say, hey, can I have fiber? They're like, yeah, if you're with us for a year, then we'll just do it for free. So they set it up for free. So let's see. Oracle, Salesforce. We already talked about cloud. All right, we got to cover those topics. We talked about it in general. We'll talk about it a little bit. I don't want to fry too many brains. In general, what I've described is that you are a cloud customer. What do you really need to have an infrastructure at your location? So let's take a look. This location, we'll say, has 10 people in an office, and they need connection to servers, to email, to everything that a LAN provides. So what you would have is wired in here, 10 connections, all going back to a switch. The switch would then be plugged into the router, and the router would come out to the internet and come to whatever cloud services you are using. And as I said before, this makes it super cheap. What would have happened prior to all of these cloud things, and why do we have these cloud services? Because the internet's fast enough now. Before it was not fast enough to do it. So in the past, you would have wired those 10 computers together. You would have bought an email server. You would have bought a file server. Might have been on the same system, might not have been. And so your startup costs were going to be a lot more. Because not only did you have to buy that hardware, you have to hire somebody that knows how to set it up, make sure it's running, keep it secure, all that stuff. So if you're the person, you start your business and you know how to do it, you save some money. Otherwise, you're going to hire somebody that you guys would be working for to come in and make that happen. So you're going to have these servers that cost a bunch of money, install the operating systems, do all that fancy stuff in order to just have what these are providing for you. Right? They're not there. They don't exist. You can't do it. So now you just buy 10 computers, somebody comes in and puts in some network cable, puts it into the switch, and then talks to, has your router, and then the router's no special setup. It's a little bigger than what I'm using, but $300, $400, you just put this router in, and now you can talk to any of your cloud services, and that's where your files are, that's where your email is, that's where your database system is, everything is set up out there. So that's what they are getting into now, is what are some of the terminology that we use for doing that? So SD-WAN is a software-defined WAN area network, relies on abstracted, centralized control network devices to manage network functions. Right here, I've got a server, I've got switches, I have my LAN set up right there. So if you guys tie into the Wi-Fi ties into that server, and there's about 5 VMs that are running on. And there you go. It's a done deal. Okay, so how do we do that here? Well, we do it in their software defined. So you define that WAN in the software. And that's what I meant a long time ago when I said, oh yeah, they wanted us to teach Amazon Web Services here. But Amazon Web Services briefly talks about some of these networking stuff, and then they throw you into that crap. So if you don't understand that there's this thing called a server, and it's plugged into other servers, and that they all plug into a switch, and they all plug into a router, you ain't doing that. Because that's what you have to do in software. You have to make those things in software. Of course, these days you don't have to program it at all. You don't have to go and okay, my server's going to do, let me put in some code. They've done that for you, but you still have to select it, and then you have to say, this is what this is doing. You already have, if you want to mess with this, usually students are doing enough, right? It's like, I got enough to do. I don't want to do that. But if you're interested in it, through your Microsoft account, you already have an Azure educational account. So if you go to Microsoft Azure, you can put your information in and you'll log in, and it'll be right there. It'll say, you want to spin up a database? Here it is. Click here. Of course, then comes all the questions. That's where you have to know, what am I doing with this database system, right? It's not going to click it and just do it for you. We'll get there. You know, AI will eventually ask you 7 questions and spin that up for you. But right now you need to know it, but you can do it now. And just to let you know, Microsoft Azure has a ton of educational stuff. So you can look and say, how do I spin up a database server? And it'll run you through it. And they'll have little questions that you answer. And yeah, it's pretty cool. All right, so what does this kind of WAN offer? Transport agnostic, meaning it doesn't matter what technology you would have had to use before. Active load balancing and automatic failover, right? This is all running on their massive servers, as I showed you pictures of them, just a bunch of lights in a room. They'll deal with that. If your database kicks up and really starts running hard, they'll take care of it. It'll just automatically allocate what it needs. Way you go. Now that's dependent on your price, right? So up to a certain point, and then they're going to call you and go, hey, buddy, looks like you need to pay more. And then you can either stay slow or you can go up. Intent-based management, meaning what's your intent of this server? You don't have to do all the other stuff. That's the thing that, I don't know, we don't really talk about that. I'm starting up a server class. It'll be next semester. You guys don't have to take it because you're already in the program. But I'm starting that up, and we don't talk about that. We don't talk about the fact that, okay, you have this piece of hardware, then you put on, say, Microsoft Server 2024. Then you go in and select, what is this server doing? And then you make those settings. And then somebody manages that within. So if you say, okay, I'm gonna tell this to be a SQL server, because we use that all the time. There's a whole person that's going to manage that SQL stuff. So you, as the person that set up the server, you don't manage that. There's somebody else, because that's like a whole other world. That's like going to your general practitioner, and what your general practitioner is going to do is, wow, I can't figure out what your leg problem is. We need to send you to a specialist. It's way too much information for them to figure out every single thing that it possibly could be. This is the same thing. Different people. That's why I tell you there's hundreds of thousands of different jobs out there. You just don't know it yet. You'll get involved in something and then you may go, oh, I really like this. And you get more involved in it. And again, people in IT are really nice. They know that's the situation. So you might start out as a frontline customer tech. And then they're like, hey, you want to see this other stuff? Because they know, look, you got some skills, but I don't know what you're going to be interested in. And there's hundreds and hundreds of things you could do. And they invite you to come take a look, and you take a look and you go, oh, yeah, this is really cool. Oh, you want to learn some more? There's all sorts of things you can do, even within security. So when they're looking at intent-based management, it's like, you don't have to do all the lower stuff. My intent is to do this with the data system. So I can go ahead and select that template and get it going. The zero-touch provisioning has to do with this load balancing. When you provision something, you're basically setting it up to have a certain amount of, you're going to provision a storage. I'm going to give this 10 terabytes. I'm provisioning that. You don't have to do that. They do it. And guess what? They've already got the software running. So technically the server people don't do it either. It's all programmed in. And that all results in reduced cost, because they can do it at scale, right? They can get tons and tons of servers in there, thousands of them, and then sell them to millions of people. That means they can lower the cost of that, instead of every single one of those places having 2 servers themselves. So reduced cost is very important. That's why people do it. And they show you some examples of how that's going to work with the WAN. Let's see. Oh, yes. Cellular technology. So shifting gears, right? You see those commercials for AT&T and Verizon, when the state of whatever wanted to blah, 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 they called us. Maybe you don't get those commercials. And it's like Verizon, we went in and set up towers, and they show some truck with this tower that they just lift up and get things going. That's what political note. It's amazing how people are just like sheep and just switch. You know, like how Elon Musk was the savior of everything, and now he's hated. Yeah, that's a pretty big sign that some people are doing some pretty bad stuff. They want him gone because he found it. And I'm sure he knows who's done it and where the money's going. So now it's like, we don't like you anymore. But why do I mention that? Starlink. And he's over so many times he's gone in and said, this place has been decimated. They have no cell towers. They have nothing. Here's Starlink. All you got to do is set it up and shoot it to the satellites we have and we're ready to go. That's not this. Starlink, it's different. Why do I mention it? That's where we're going. Not going to just be him. All these services, AT&T and all of them are going to start doing that instead of this. Now, it doesn't mean this will go away. What you have to know, though, is that this is all a bunch of crap when it comes to how much speed do you get. Because they've done these generations. And that's how they can all stand out there and go, we got the fastest 5G. According to blah, 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 blah. Right? They put in all these different things and all of them have the fastest 5G apparently. Well, if you realize what's going on, first G, that was analog. That's going back to the 80s and 90s. Second G, that's what you got out of it, 240 kilobits. Third generation bumped you to 384. Fourth generation, now we've got IP networking and voice over that. And then 100 megabits to a gigabit in fourth generation. That's a wide range. Yep. So that means you can go in and say, we got 4G. 100 megabit. Theirs is 1 gigabit, but it's still fourth generation. So, and then fifth generation. Minimum speeds of 1 gigabit, 20 gigabit uploads, speeds of 10 gigabit. It's a lot of stuff shooting through your brain. That's all I'm going to say. Fast. People want fast. That's how it works. You got all those towers all over the place. They communicate with each other. The area they cover is known as a cell. It's still going to be slower. You should understand that. If somehow you had a physical connection from your car to this office, that would be a ton faster. It's not realistic, but it would be really fast, right? Because you're here and it's going to go, I need to talk to that tower, that tower, that tower. Then I'll get into the state. You're still making these wireless hops. And there's all this control information to make sure those hops are happening. So there's more overhead. That's what I should say. And then our low orbit satellites, which is what we're talking about. So at this point, right, this was never in this networking information, but it's becoming the thing. It's becoming the next big thing. So they're trying to tell you, okay, we need to tell you some basics about this. If you didn't take a science class where they talked about any of this, we need to look at how these things are orbiting the Earth, because that will affect what it can do here. Most are in geosynchronous orbit. What does that mean? This is a good one because all you have to do is look at the word geo. So we're looking at something geographic, and it's synchronous. So the satellite sits above a certain spot on the Earth, and as the Earth rotates, the satellite rotates with it. So it's always above Arizona, if that's where they put it. Satellites orders the same rate as the Earth turns. Information is transmitted to the satellite in an uplink from an Earth-based transmitter. A satellite transponder transmits a signal to the Earth-based transmitter as a download link. And then geosatellites are the type used by most popular satellite services. So yeah, if you get on your cell phone and you decide to call somebody in France, chances are you're going to hit the geosynchronous orbit satellite here. It's going to relay it to another satellite that's over Europe and beam it down. So you're going to have an antenna that's talking to that. So in today's world, you don't have a satellite phone. So you're on a cell phone, it hops through the cell, finally hits the infrastructure, finally hits where the transmission to the satellite happens, hits the satellite, satellite transmits it to the next satellite, then it transmits down. And that's why like I've said before, I love it. They're getting smarter and it's not fun. I hate it when they're getting smarter. But you get those people on the news and you just look like an idiot because they're over there talking. Okay, let's go to Joe over in Florida. Oh, hey. Right, that's the delay. That's how long it took for Joe to actually get that in his ear. That takes a while. So it's slow. Handful of companies offer high bandwidth internet through this. And honestly, it's like if you're in Wyoming, that's the only way it's working for you. Otherwise, you're using a dial-up telephone. It's not going to be great. Starlink is one of those that does it. Probably a good place to stop. Unless you want to talk about some connectivity issues, we can do that. No? No takers? All right.